Good evening, everyone. I am Sivagami Priya, uh, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science. Today, I am going to talk about the derivation tree in Theory of Computation. Okay, the derivation tree is a fundamental concept in TOC that illustrates the process of generating strings from the grammar rules. Then it will provide a visual representation of the syntactic structure and production processes in all in informal languages and helping to understand the relationship between grammar and the languages generation. Okay, the next one, introduction to the derivation tree. Derivation tree is a nothing but it is a derivation tree. It will looks like a tree representation that is called the derivation tree that shows the applications of production rules in a grammar to generate the string in the formal languages. Then why we are using derivation tree and what is the importance in TOC? Okay, let's see. Derivation trees are crucial in understanding how grammar generate languages, aiding in passing a syntax analysis in compiler design. The next one, a relation to parse trees. The relation to parse trees means while a derivation tree focus on the production sequences, parse tree empathize in hierarchical structure of strings. Okay, the next one, components of the derivation tree. There are three components of the derivation trees. The first one, nodes and edges. Then each node represent a grammar and grammar. Each and every node it will represent a grammar symbol, and while edges significant production zone. Okay, each and every node it will represent a symbol and production rules and edges. The next one, the second components, it is leaf node. Leaf node, it is a head node corresponding to terminal symbols of the generated string. It will representing the final output. Okay, this is a second component. Third component, internal nodes. Internal nodes, it is a nothing but it will indicate non-terminal symbols like A, B, C. That is called non-terminal symbols. S, okay, small letter, alphabetic letters. The next one, and there it is the production rules showing intermediate steps. Types of derivation. See, there are two types of derivation trees are there. The first one is a leftmost derivation trees and rightmost derivation tree. Leftmost derivation trees, it is a nothing but we can draw the tree like a tree representation. We can derive the symbols only left values only. That is called leftmost derivation trees. When we are going to derive the values from the right side values, that is called rightmost derivation trees. These are the two types of derivation trees. Okay, well, leftmost derivation trees and rightmost derivation trees. In a leftmost derivation tree, the leftmost non-terminal is always expanded first. When we are going to expand the non-terminal, that is it will here I think left side values only we can expand it first. That is leftmost derivation trees. Rightmost derivation tree, it is nothing but it will expanded the rightmost values terminals only we can expand it. That is called rightmost derivation. This approach is common, is a bottom up parsing tree. There are two methods are there in derivation trees. One is top down, from the top to bottom. The next one is bottom to top. There are two methods of derivation trees, and it will may lead to more efficient parsing in certain scenarios. The next one is these called as leftmost derivation trees and rightmost derivation trees. The next one is ambiguity in derivation trees. Ambiguity in derivation trees means nothing but we can we can give the more statement in a CFG grammar, then it will give only one string. It is called more than one derivation tree exists for a single string. Each and every string has same CFG, means that is called ambiguous grammar. Okay, a grammar is deemed ambiguous if more than one derivation tree exists for a single string, that is called ambiguous grammar. Applications of derivation trees. Application derivation tree, it is a syntax analysis in compilers. Okay, syntax derivation tree play a vital role in the syntax analysis phases of compilers, helping validate source and source code structure according to the grammar. The next one is a natural language processing. Natural language processing is nothing but NLP. It is called NLP. Formal language theory means it is a theoretical computer science derivations. It will help classify formal languages to develop the algorithms for the language properties.